Physics. Woo! All right. So physics, we've talked about kinetic and potential energy. We've talked about transformations of energy. We've talked about nuclear energy, but the summative assignment that I have for this one is one of my favorite, and I kind of happened across it by accident because one year I had to teach PE, and while I was going through the cupboards, I came across bows and arrows. Now, only one other teacher at the school had been teaching using the bows and arrows, and now they live in my classroom while I get things sorted and get the whole things kind of like strings and arrows and whatever. Now, the nice thing with this assignment is that you do not need to use bows and arrows. You could use slingshots. You could even go as far as to make the kids make slingshots that they researched first on how they work and then still do the same thing that I do with them. So with this assignment, I firstly teach the kids how to use bows and arrows safely. I'll let that be up to you if you are going to bring somebody in that has bows and arrows. These are recurve bows, not compound bows. That involves more systems of pulleys, etc., that you can totally teach and adapt into. But for me, it's a simple recurve bow with a simple arrow, nothing fancy, and a big foam target to shoot it into. Where we go with this, though, is that this is an application assignment. So we're applying the concepts that we've learned of potential and kinetic energy and all of the different formulas that we use in Physics 10 to turn it into a biomechanical study. So I introduced the concept of biomechanics to the students as like the study of movement and how we do things with our bodies. There's a question at the very end of this assignment that has to say like, well, what muscles are we doing all of this work with? And the smartest kids go online, find the picture of somebody doing archery, and it shows all the muscle groups, and then they list them next to the picture. But really, we're trying to get the kids to talk about the transformations of energy as they go from as far back, and the most deep thinking kids will go as far back as the food that they ate for breakfast as the starting energy source. And if they really want to go crazy, they could go all the way back to the sun, plants, food, us. But really, it's looking at the transformations of energy, one formula to the next formula to the next formula. So that shows me that they understand the math concept of what we're doing and what we've been doing in physics. And then the application questions are all thought driven, and they're unexpected questions as I've got them listed here. So where is energy lost in their systems? Is there more than one place that energy is lost? When you hit the target, what's the last kind of energy that's actually created? There's one that is a massive curveball that requires the kids to think about like what they were actually doing as they were doing archery, which is when you pick up the arrow off the ground, you're actually adding in potential energy into the system that one kid out of 10 or one kid out of 30 will actually get that on their own. And then I have them do a theoretical application of if you shot an arrow on a 45-degree angle, what would that look like? And I'm looking for them to talk about the transfer of potential and kinetic energy through that flight path of the arrow as it goes up and comes down. And again, the kids that are going to go and look online for the information will then take that information and apply it into their own language there. But really what we're doing is looking to see if they can apply the physics that we've been learning into a new situation, and even having to look up one or two new things to make bows and arrows work, like the elastic potential energy, which isn't actually part of what we learn or what we talk about. So this one's loads of fun. It gets you a day outside. It gets you 2 days if you're going to make the kids to actually research and then create their own bows and not bows and arrows, but slingshots, right? So there's different things that you can do depending on your freedom at your school, the space you have, and what you actually want to do. But they're there's a lot of application here for the physics that we do, and it leads them and sets them up into the grade 11 physics that they're actually going to do as well. So this is one that I really like. It's a lot of fun for me to go outside and be outside of the classroom, in the real world, but it's a good time. So yeah, have fun with it. Bye.